Right, so we are going to talk about 55 new features in JDK 9. Originally, this was prepared as a 1-hour presentation. I now have 49.25 minutes, so we are going to move at a fair pace. But hopefully I can give you a taste of many of these features and ideas about what they actually do and how they are useful to you. Right, so the first set of things I'm going to talk about are the major features. Obviously, the biggest of these is the Java Platform Module System, or Project Jigsaw. I could obviously spend an hour at least talking about that, but I'm not going to spend very long talking about that at all, because I want to focus on a lot of the other things. But there are a couple of things we should say about that. So the first of those is the JSR. So JSR 376 is the JPMS. That went through a vote a few weeks ago. The JCP Executive Committee actually voted against it. That wasn't a negative thing in the sense of JPMS. It was actually that the Executive Committee, which I'm actually on through Azul, didn't feel that it was quite ready. They needed another month to make some changes and get things the way that people wanted them. So we're now in the middle of that vote. I won't say anything about that specifically because there's still a few days left for voting, but I think that there will be a good result at the end of that. Now, in terms of modularity and Jigsaw, let's just talk a little bit about that. One of the changes that you're going to see is modularization of the core platform itself. We're moving away from this monolithic rt.jar with 4,500 classes in it to a set of modules. And if you look in the JDK 9 directories, you'll find that, well, as of the last time I looked, there were 94 modules. And there are now JMod files rather than an rt.jar. The other big change that is going to impact on some people's code is the encapsulation of internal APIs. This is taking all of the non-public APIs in the JDK and making them invisible to your code. This has caused a lot of discussion, it's caused a lot of issues, because even though people have been told right from the very beginning that these are internal APIs, they're not documented, they're not public, you shouldn't be using them, obviously people have. The most infamous of those is good old sunmisc unsafe. I particularly like this one because the clue is in the name, unsafe. But because people have used that, decisions have been made around the JPMS, and there are now two options that you can use, ---- add exports and ---- add opens, which allows you to expose the internal APIs that have been encapsulated so you can still use them within your code. Now, in terms of exports, what that allows you to do is actually import them into your application code so you can use them directly. And then the opens is about getting reflective access. So if you need to access them through reflection, you can do that separately from importing them in your code. The other thing that's being done is modularizing the source code itself. So reorganization of the source code for the JDK, for the libraries, and this is not specifically part of the module system. Now, talking a little bit more about Jigsaw, compatibility is something of an issue. As I said, the encapsulation of the internal APIs means that some code needs to have these extra options. You need to be able to override that in certain situations, especially with frameworks. Frameworks is some of the things where you see this more often. What you can do to ensure compatibility is, in effect, to ignore the module system for now. So you can say, OK, I want to take my application and run it on JDK 9. Rather than dealing with the module system at an application level, what I will do is simply leave everything on the class path and not convert my code to modules. That way, you don't need to worry about resolving against the module path and some of the issues that you get there. And then the other thing you can do is you can use what's being called the big kill switch. The big kill switch is effectively an option that's available on the command line that turns off the encapsulation and the way that reflection is affected by JPMS. Now, this was originally a single option, which was ---- permit illegal access. That has recently changed in the last couple of weeks, as part of the reconsideration of the specification into an option called ---- illegal access, which has 4 different options associated with it. There is permit, which will allow you to do illegal access. And every time you do some sort of access which is deemed illegal, whether it's reflection or whether it's accessing an API, you will get a single warning. Subsequent times that you do that, you won't get another warning. So you only get 1 warning per access to a given API. There's also warn, which will give you more information. It will give you a warning every single time that you access an API. There's debug, which will give you more information about how you can try and change things to avoid this. And then there's deny, which effectively turns off the illegal access. So rather than using the default, which is permit, you can turn it off and then see if your application will run. Related to modularity is jlink. And jlink is designed so that you can create a runtime specific to your application. And what I mean by that is that you can take your application as a set of modules and generate a runtime directory image which contains the Java VM, it contains the modules that are required only by your application. That way you don't have to shift all of the modules that are available in the JDK. You can trim it down and reduce the size of your JRE. This has advantages if you're dealing with constrained devices, if you're doing things like IoT, embedded, that's one good thing. But it's also very useful if you're doing things like microservices and you want to minimize the size of the image that you're going to use in your container. This can be very useful. The way that works is you simply say jlink, specify the module path, where your modules are going to come from, and then which particular module you want to start from. So if we do a simple one here where we just use java.base, which is the module that you have to have in every single application, and then you do a run Java from the directory that's being created for you, and you say ---- list modules, you will see there's just java.base there. If we did that for a slightly more realistic example where we've got an application that's been developed as a module, what we'll see is we can simply specify the module for our application. All of the dependencies will be analyzed by the runtime, by the jlink, and that will then create a list of modules that we can see there. So we've got java.base, logging, SQL, XML, app, Zoop, and Zeta. Great. The observant amongst you will see that there is a number associated with each of those modules. And you may be getting excited. You may be thinking, oh, look, we have got versioning of our modules. Do not get excited. Versioning, numbering is for information purposes only. It has no impact on how things are resolved by the platform module system. And in fact, I put a quote here from the state of the module system, which says, it is not a goal of the module system to solve the version selection problem. Right, moving on from Jigsaw. Other things that we get as sort of more major features. From a library point of view, there are now factory methods for collections. So we have the list, we have the set, and we have the map interfaces. But when we want to use those and create a collection which has an initial set of values, we can't do that very easily. The code that we need to write is quite verbose. And in fact, if we look at a simple example, what we'll see is that if we want to create an immutable set with 3 values in it, what we've got to do is create a new hash set, then we've got to add value A, value B, value C, and then we've got to create from that an unmodifiable set as a new reference. So we need 5 lines of code. With the factory methods that are being provided in the collections interfaces now, we can do that with a single line of code. So we can simply say set equals set.of ABC. Now, one of the reasons that we can do this now is because of the fact that we can put static methods in an interface, introduced back in JDK 8. The way this has been done is using a number of overloaded methods. So there are overloaded methods for 0 to 10 elements to create the collections, and then there's another overloaded method which takes a varargs parameter so you can provide as many elements as you want. The idea of having 11 different overloaded methods, or 12 different overloaded methods, is to get better performance out of that. We have some enhancements to streams. Two of the methods that have been added, drop while and take while. And if you think about the streams API at the moment, you have two methods called skip and limit. What they allow you to do is to say, I want to take this stream, but I want to skip the first n elements of that stream. So I'm going to ignore those n elements before I start taking elements from that stream. Similarly, you can have limit, which says I only want to take the first n elements from the stream and then stop taking things from that stream. Drop while and take while work in very much the same way, except that rather than having a predefined integer value of how many elements you want to drop or take or limit, what you do is you use a predicate. So you can say drop while, have a predicate which has a condition that needs to be satisfied in order to start taking elements from that stream. Similarly, take while has a predicate where it has a condition that needs to be satisfied in order to stop taking elements from that stream. One thing I would quickly say about that is that you do need to be aware that if you're using an unordered stream, you may get a situation where you take elements, if you're using take while, and then you stop, but because it's an unordered stream, there may be elements further down that would have satisfied the situation of being able to take those elements, because the predicate only has to be satisfied once in order to change the state of the elements being taken from that stream. There is an improvement to the iterate method. Up until now, you've had two versions of iterate. So you can iterate with a value, and then you can have iterate with a value and an iteration function. So you can say how you want the value to change through each iteration. Now there's a third method associated with that, which makes it look just like a for loop. So you have your initial value, you have the condition that you want to be satisfied to stop that iteration, and then you can have the iteration function. So you can make it look just like a for loop. Files.lines has now been converted so it will work with parallel streams. This can be very useful because if you're trying to read things from a file and you want to process that in parallel, if you were doing it before, the problem is that the lines were being read from the file sequentially. Even if you try and spread those out into a parallel set of threads, the performance is not really going to be that great. By doing parallel operations on files.lines now, what happens is that the file is mapped into memory, and then the area of memory is divided up into, hopefully, roughly equal chunks based on the number of threads you have. And that way, each thread can have a pointer into that area of memory and can draw the lines from that and actually process them in parallel. So you get a very big improvement in performance for that. The next thing is on the optional class. What you get now is another method which allows you to retrieve a stream from an optional. And I know when I was talking about optionals back in JDK 8, I often used to say that you can think of an optional as like a stream of 0 or 1 element. Now you can actually get a stream of 0 or 1 element from the optional. So you get 0 elements in your stream if it's got a null reference, and you get 1 if it's actually got a valid reference. Multi-release jar files. This is an interesting idea for more sort of future use, because what the designers want to be able to do is to say, okay, if you have code that depends on a specific version, rather than having to ship different jar files to support the different versions of the JDK, what you can do is actually include the code for those versions in a single jar file. And then the JVM itself will be able to say, okay, I'm version 9 or I'm version 10. I will use the appropriate version from that jar file for the version of the JVM that's actually being run. Now, at the moment, you might think, well, okay, so we're introducing this in JDK 9, so the only version that I can actually use is JDK 9. So multi-version or multi-release jar files is actually only one release. But it's a little bit more clever than that, because you can actually use 2 releases. You could use JDK 9, and you can use one version prior to JDK 9. So you could say, okay, I'm going to have JDK 8, And as long as you put JDK 8 version as the default at the top of the jar file, that will be used by a JVM that is not aware of multi-release jar files. If you use JDK 9, the JVM being aware of multi-release jar files will look in the appropriate subdirectory of that jar file to find the relevant files that it needs for that. In terms of changes that have been made, various things have had to be modified, things like the class loader, things like the jar file API, and a number of the tools, Java-C, Java-P, and so on. REPL, JShell. This is the idea of a read, eval, print loop. And many languages have this, so that you can try out little snippets of code and see how they work without having to fire up your IDE, create a project, create a main, create all the necessary code, and do it that way. If all you're interested in is a few lines of code, then you can do it with JShell, and you can experiment and you can see exactly what's going on. There's all sorts of things you can do, the things you would expect, like being able to do a history, so you can wind back and see what commands you've typed in. There's autocomplete, so it makes life even easier for you. And even a lot of the semicolons are optional because of the way that the code works. I must admit, when I first started using this, I thought to myself, oh, well, it's kind of a nice feature, but I don't see myself using it a great deal. But I have found that there are definitely times where I've been trying to figure out how a little bit of code works, and rather than going to the trouble of actually creating a whole IDE project, you can just fire this up and type in a few lines of code, and it's like, that's how it works. Concurrency updates. A few things that have changed around here. First of those is the idea of reactive streams. This is something that's become very popular over the last couple of years, and there was a nice talk about this by Venkat yesterday, where you can see how this kind of idea works very well if you're trying to stream data from different places and process it. Now, we already have the Streams API in Java, but this is more about sort of a higher level. Rather than taking like a collection and streaming that, what we're talking about is having like a remote client that is requesting services from a server. Okay, now that's all good, but it may be that the client needs to be able to understand how many requests it can send to a specific server before that server gets overloaded. The idea of the reactive stream that is used in Java will allow you to do that. So it's based on the idea of what's called the Flow API. Flow API, publisher, subscribe. So the way that actually works is that if you've got like a web client and a web server, the web client is actually the publisher, and the web server is actually the subscriber. So it subscribes to messages coming from the client, and it will tell the client how many messages it can subscribe to. So if it can handle, let's say, 4 messages before it gets overloaded, it'll tell the client that it can send 4 messages to the server quite happily and get results. Once it gets to that 4 limit, the client then has to decide what to do. Does it block and wait until the server says, I can handle some more requests, or does it say, okay, well, I'm going to load balance and I'm going to go to a different instance of that server and start getting requests there? So that's the idea of the publisher subscribe kind of idea. You can also chain these things together so that you can have processors which are both a publisher and a subscriber. So you can link a publisher to a processor to a subscriber. And the way that things are handled along that chain is through a subscription. So that's how you actually tie these things together. There's also a submission publisher utility class that allows you to do asynchronous items for a current subscriber, and that in itself implements the flow.processor interface. Another concurrency update is the completable future. And I'm just going to have to remind myself, because I need one thing here. Yes, good, okay. Right, so the completable future was introduced in JDK 8 because futures are very nice because they mean that you can create a separate thread of execution but return a result in a standard way. With a thread, you start the thread, it executes, but there's no way of returning a result directly. Futures allow you to do that. So you can create a future, and then you can call the get method on that to get the result. Problem is that that can block So you might end up blocking while you wait for the result to happen. If you want that to happen asynchronously, then completable future solves that problem. So you can have a completable future, which you can say, here's what I want to happen, here's the callback method that's going to get used when that thing completes. And that way the callback method gets called, and then you can use the result you've got. So that all works very nicely. And there's a few additions that are being made to completable future in terms of JDK 9. First is that there are some new methods that allow you to deal with delays and timeouts, so that you can specify how long you want to delay or how long you want to wait for something. Also, better support for subclassing because of the way some people use these things. And then there are some new static utility methods, and this is where things kind of get interesting. So one of the things that completable future gives you is a completion stage. And completion stage is the idea of how you might want to have several tasks linked together. So you can feed the result of one to another and do that asynchronously, so it actually happens in the right order. So there is a new static utility method called minimal completion stage. I'm going to read you the description from the Java docs of minimal completion stage. Minimal completion stage returns a new completion stage that is completed normally with the same value as this completable future when it completes normally and cannot be independently completed or otherwise used in ways not defined by the methods of the interface completion stage. If this completable future completes exceptionally, then the returned completion stage completes exceptionally with a completion exception with this exception as cause. It's all English, but I have no idea what it does. I've read it about 3 times, and I still don't quite get it. They also have this failed stage, which is how you can actually define things when you're linking completion stages together. And then there's 2, which I just like the names of these, a new incomplete future and a failed future. So there is new static methods. Enhanced deprecation. So we've had deprecation right from, well, not quite the beginning of Java, but from 1.1. And in 1.1, there was the @deprecated javadoc tag that was introduced to indicate that certain elements in the API should no longer be used, because they're either better alternatives or the ones that are being deprecated should no longer be used. In JDK 5, we then introduced the @deprecated annotation, so that we could have more tools that worked with that. Problem is that there's lots of things that this doesn't really address in terms of the needs of deprecation. So now in JDK 9, there are 2 new methods that are added to the annotation that allow you to get more information. So the first of those is forRemoval, and that has a value of either true or false. What that really tells you is that if it's marked as true, then at some point in the future, that element will be removed, or the intention is to remove it at some point in the future. If it's marked as false, at that time, there is no intention to remove it. So it's left there because it's still useful, but there are better alternatives that you might want to use. The other thing that's included now is the since method, which returns a string. And the idea here is that you can find out at which version of the JDK that particular API was deprecated. Now, I will say that they haven't gone back and filled in all the details for all of the deprecated elements there are in the JDK. It would be an awful lot of work, and it's really only for kind of historical purposes. But everything kind of moving forward will have a since value associated with it, so you can see when it was deprecated. Several new things have had the @deprecated annotation added to them, and there are 2 that have had the deprecated tag removed from them. And this got myself and some people into a discussion about what's the opposite of deprecation? Is it de-deprecation or is it precation? I leave that to you to decide. There's also a tool that you can use called jdeprescan, which will take a jar file and will scan it and give you a report on any APIs that are being used there which are deprecated. Milling project coin. Small changes to the language. There are a few of these. The first of them is the single underscore is no longer valid as an identifier. So this is kind of interesting. Who here has used a single underscore as a variable name? I don't see, oh, a couple of hands. Okay. Well, in JDK 9, you're no longer going to be able to use a single underscore as a variable name. The reason for this is that in JDK 10, the intention is to allow a single underscore to be used in a lambda expression. If you have a lambda expression that has a single parameter, which is not used in the body of the lambda expression, using a single underscore kind of helps to hide the fact that there's a variable there. So it sort of makes some sense. For those of you dedicated to the use of a single underscore as a variable name, I checked, you can use 2 or more underscores as a variable name, and it still works. Next change is the inclusion of private methods in interfaces. Interfaces obviously got a big change in JDK 8, so we had the introduction of default methods, we had the ability to include static methods. Because we now have behavior in an interface, it makes sense to include private methods in an interface so that you can have a number of static methods that can also use a private method, or you can use default methods that use a private method and share that code. So it makes sense in that respect. Effectively final variables in try with resources. If you had a variable for, let's say, an input stream already in your code, and then you wanted to use try with resources with that variable, then you still had to declare a new variable name, even though you had a variable for it. So you just had to declare a new variable name and assign it to the existing variable. That's a little bit fiddly and doesn't really add any benefit. So in JDK 9, if the variable that you're referencing is effectively final, meaning it is either marked as final or behaves as if it was, then you can just use that variable name in your try with resources block. So it makes life a little simpler. Safe varargs is now available on private instance methods. If you look at the description of safe varargs, which I won't spend too long talking about, basically you can use safe varargs on a constructor, a final method, or a static method. These are all methods that can't be overridden directly in a subclass. Private methods also can't be overridden, so it makes sense to use safe varargs in the same way. And the last thing for Project Coin, or milling Project Coin, is now the ability to use the diamond operator with anonymous classes. If you looked at JDK 8 and earlier, you couldn't use the diamond operator with an anonymous class because the way that the compiler could generate code is you could have a non-denotable type which the compiler could generate, but the JVM couldn't understand. This is a fairly obscure kind of thing that you might have happen. But now, if you've got a situation where the compiler can generate a denotable type for that anonymous class, then you can use the diamond operator, and the compiler will fill that in for you. Basically, when you use your IDE, it'll tell you whether you can use diamond operator or not. Changes in terms of standards. So there are many standards which Java adheres to, and some of these have been updated to account for the latest changes. So Unicode, this is one of my favorite ones. So there have been 2 releases of Unicode since JDK 8, Unicode 7 and Unicode 8. Unicode 7 introduced 2,834 new characters. And then Unicode 8 introduced 7,700 new characters. And I thought to myself, okay, I need to know more about this. Where did all these symbols come from? Because, most of the languages have already been covered. And what I found was that in terms of Unicode 7, there were a lot of symbols added which were emojis. So that's where a lot of those came from. And then in Unicode 8, we got a lot of things that were emojis as well. Unicode 7 also added a symbol for the new ruble, and also for the manat, which is the Azerbaijani currency. And then Unicode 8, quite an interesting one here, introduced lowercase Cherokee. Apparently they had uppercase Cherokee, but now you have lowercase Cherokee as well. Other standards have been updated, so the public key cryptography system is now being used as key stores, so moving away from the Java key store system to the PKCS 12 way of doing things. Java docs have now been updated to HTML5, so we have some slightly nicer looking documentation, and the algorithms used for SHA-3 has been updated. trying to keep us ahead of the hackers. Some other smaller features that have been changed. So property files now can use UTF-8 encoding, which means they can use Unicode. What does that mean? It means that for our property files, we can now include emojis, or we can use lowercase Cherokee. Wonderful. Another thing is the DRBG-based secure random implementation. Apparently, DRBG stands for Deterministic Random Bit Generator. Now, I don't know about you, but I would have thought random was non-deterministic, not deterministic, but I don't know. And then the last thing was XML Catalog API has been updated to version 1.1 of the Oasis XML Catalog version used in JAX-P. Some changes inside the JVM. What's happening here? Well, the first of these is that the default collector is being changed for server class machines to G1. What do I mean by server class machine? Server class machine is defined by Oracle as one that has 2 or more cores or processors, 2 or more gigabytes of memory, and is not running Windows. So that's when we get to use G1. At least I think that's still the case. Maybe I'm wrong on that, but that's certainly what used to be the case. So G1 has been around for a long time. It's an interesting approach to garbage collection. It is using the concurrent mark sweep algorithm, but with the idea of doing some concurrent compaction as well. Some changes that have been made around that to improve efficiency are things like concurrent class unloading. That was introduced back in JDK 8 to make it better. But the one thing I would say is that G1 will still fall back to a full compacting collection. So if it can't keep up with the rate of allocation, then you will still see very long pauses associated with compacting the old generation. If you're interested in pauseless garbage collection, then have a look at Zing. That's my marketing slide there. Better string performance. A few things around improving performance of how we deal with strings internally in the JVM. So one of those is the idea of compact strings. Now, this is not about trying to actually compress strings. It's not trying to use compression algorithms on them. It's just using the space of the strings that are there more efficiently. The other thing is the idea of the storing strings so that it can be shared between JVMs. So if you're working with the kind of application that has an awful lot of string data, a lot of textual data, and you've got several JVMs all working on the same data, rather than each having to have its own copy, there's a thing called the class data sharing archive, and you can use that and share the objects so that different JVMs don't have to have their own instance of that. Improvements around string concatenation is using the invoke dynamic bytecode that was introduced in JDK 7. And this is really, again, to improve the efficiency of how this works, some nice low-level stuff. But it also allows, because we're moving away from defining the way it works in the bytecodes themselves, to letting the JVM decide at runtime that there are some future improvements that can be made based on this as well. The Marlin graphics renderer is being replaced. So right now, if you look at OpenJDK and you're using graphics rendering on screen, what you're going to be using is an open source graphics renderer called Marlin. That doesn't have quite such good performance. So if you look at the graph there, the green line is the Marlin graphics renderer. And high is latency, so high is bad. So you can see that it's higher up. What Oracle have done in the past is they have replaced Marlin with a closed source implementation called Ductus. And that has a better performance characteristic, which you can see from the, I think it's the red line on the graph there. And then what's happening now is that there's a new open source renderer called Pisces, which replaces Marlin and has very similar performance characteristics to the Ductus one. So you basically get better performance for graphics. Some smaller features, improved contended locking. This is very low level in terms of the way the JVM works with the hardware. So it'll look at how to do some reordering of fields, how to do better cache alignment to improve what happens when you're contending over a lock. Also, the idea of using hardware to accelerate some of the encryption hashing algorithms and things like that. What they've found is that using this and using CPU instructions at the silicon level, you get somewhere between a sort of 34 and 150 times better performance for certain tests. So your mileage may vary. And then for anybody who's using JavaFX, the GStreamer way of streaming or presenting media is being updated to the latest version, better security, stability, and so on. A few other smaller features. So the segmented code cache. This is the idea of separating the code that's generated by the JIT compiler into a number of regions. So you've got non-method, profiled, and non-profiled code. And really that's about separating things up so that different improvements can be applied to different regions of code. Before it was all mixed up. Now by segmenting it, it makes it easier for future work to improve the efficiency of that. From a logging perspective, there's now a unified way of doing logging for the whole JVM. So this is within the JVM. It's not log4j or anything like that. So there's a common logging system for all the elements of the JVM. And then related to that, because GC logging is obviously something that people look at quite a lot, there is the use of the unified JVM logging system for GC logging. Specialized features. Right, so the first of those is called spin weight hints. Now, we at Azul are particularly proud of this because this is the first JEP that has been accepted, JEP being a JDK enhancement proposal, the first JEP that's been proposed by somebody outside Oracle and actually accepted into the JDK. Now, this is a really quite small change. It's one method that's being added to the JDK called onSpinWeight. Now, having said it's only one method, it is one method being added to the thread class, which potentially could have some fairly significant effects. So we had to go through a lot of steps to make sure that Oracle and the OpenJDK were happy with this. But what this allows you to do is to give the JVM hints about whether you think your code is going to spin the CPU. And so you say, if I think I'm going to spin the CPU, you can go onSpinWeight. And then if the JVM is aware of this, and if the hardware supports it, you can use something like the pause instruction on the x86 architecture. If it's not available, it just gets ignored, so there's no overhead. But if it's available, this can improve efficiency because rather than spinning the processor, it actually pauses the processor, and it reduces power consumption. And what we found is that for things like the disruptor from LMAX, this actually makes a significant difference. Well, somewhat significant. Variable handles. So variable handles are partial replacement and even an improvement over what was available in Sun, Misc, Unsafe. Because Sun, Misc, Unsafe is being encapsulated and will at some point go away, people need a replacement for a lot of the functionality that's in there. So what this does is give you the ability to do that. What does a var handle do? It allows you to do memory-specific operations around a variable. Now, some of these things are already available in the atomic package, which is part of the concurrency utilities. But the problem with that is there's an overhead because you have to create an atomic instance in order to do that. If you do that for a lot of operations, it becomes a big overhead. So the reason people use Sun, Misc, Unsafe is because you don't have to create a new class. You just simply say, I want to do a compare and set or a compare and exchange on this value and have it happen atomically on the variable itself, not having to worry about creating a new object for it. So there's things like that. There's also the ability to fence operations so that you can tell the JVM underneath, I don't want the order of these operations to be changed, even if the specification of the JVM allows it. So you're saying, I really want these things to happen in this order, make it so. Enhanced method handles, these are primarily used by people who are doing things around supporting other languages rather than Java on top of the JVM. And so method handles are used a lot for dealing with dynamic typing and how you can resolve a method based on having dynamic types rather than static typing. What the enhanced method handles gives you is support now for, or better support for things like loops, also for try-finally blocks, the way those works, Better argument handling, which I'm not going to go into because it would take too long, but there's the idea of spreading, collection, and folding, which is just how you merge or split up the arguments that are being passed to a method. And there's some more lookup functions associated with that. But that's kind of a fairly low-level feature that most people don't tend to use. Smaller features, compiler control. So this is the ability to specify a directive file for the JIT compiler. We're not talking about Java-C here. We're talking about the compiler inside the JVM. So what you can do is you can specify how you want things to happen. You can say, I want to force method inlining for these particular methods, and there's various other things you can do around that from the directive file. You can also do changes at runtime via the J command, and so you can override things and change those if you really want to. Also, some improvements around the process API. If you want to interact with native processes on the machine you're running on, then there's now ability to find out more information about those processes. There's a thing called a process handle that gives you both gives you the process ID, it gives you the arguments passed to that command, it gives you the start time, how much CPU usage has been used, name, and so on, things like that. You can also kill off processes, assuming you have the right security permissions. You can't just kill off anybody's processes, but if you've got the right security permissions, then it's easier to kill off processes. Housekeeping. Version string format. So this has changed because the version string format in Java up until now has been, let's say, a little bit confusing. What we've had is the idea of, we've had limited update releases, we've had critical patch updates, and then we have things like JDK 8 U121. So, okay, that's JDK 8 update 121. But if you look at the JDK itself, you'll find that buried in there it's actually JDK 1.8.0 underbar U121. And so it gets a bit confusing. This is because way back in JDK 1.2, or JDK 1.2, we actually got a point where marketing met engineering, and they didn't really kind of agree. So you had one version, which was Java 2, version 1.2, and then it all got very complicated. So this is going to get clearer. So now we'll have JDK, major number, minor number, security number, patch number. So 4 numbers associated with the JDK, and it's very clear what this actually means. Easy to understand by humans, easy to understand for applications, and it's much more of the idea of semantic versioning, so you can actually see exactly what's going on. The structure of the JDK itself is going to change. So in addition to the changing for the versioning, if you depend on that in your code, that might be something that breaks backwards compatibility. If you depend on where particular files are in the JDK itself, that may break backwards compatibility for your application. If we look at the existing way things are laid out, you have the JDK, which contains a bin directory, it contains a lib directory. Bin directory contains the Java, JVM executable, the lib directory contains the tools.jar file. You've then got a JRE directory, which contains a bin directory and a lib directory. Bin directory contains another copy of Java, so you've got 2 copies of Java. Lib directory contains rt.jar. Now that's all been flattened out, so you have one bin directory with 1 copy of Java. You have a conf directory which contains all of the files which you could potentially want to modify for configuration. Before, they were kind of spread around in the JDK, and it was never clear which ones were potentially ones you could change and which ones weren't. There's a lib directory for native files. There's also a mods directory that contains all of the modules for the JDK itself. No more JRE directory, no more tools.jar, no more rt.jar. Smaller features. Searchable API documentation. I have to say, this is without a doubt my most favorite feature of JDK 9. The fact that the Java docs now have a little search box, and you can type in the name of the class or the method that you're looking for, and you can go straight to it. You don't have to scroll down through this list of 4,000 classes. You can just go straight to where you need to go. Fantastic. 22 years and we've found the search box. Annotations pipeline. That's been reworked so that we have the ability, because we had the ability to do repeating annotations, Lambda annotations and things like that. So it's really a redesign of how the annotation pipeline works. From a developer perspective, it doesn't make any difference. There's now a parser API for nashorn, so if you're doing JavaScript and you want to do some parsing of that, then there's an API for that. Some general cleanup. One is the disabling of most of the SHA-1 certificates. There are still a few situations where people do need SHA-1 certificates, so they will be accepted. And the applet API is finally being deprecated. Anybody still using applets? I do not see many hands. I don't see any hands. OK. Well, sadly, that means that tumbling Duke will tumble no more. Right, removed from JDK 9. So there were some things actually being removed. First is that there are 6 deprecated APIs being removed from the class libraries. That means that prior to this, not a single API has ever been removed. 6 of them have been deemed so bad that they get to be removed. So it's add and remove action listener in the Pack 200 and log manager classes. And yeah, there's kind of 2 related to that. So you think, why were they so bad that they had to be removed? And it's all to do with modularity and how you can actually split things up. Next thing is that the JRE version selection command line option has changed. And I need to make this clear because somebody asked me this question after I did the presentation a while ago. So -version:"release" is no longer accepted. You can still do -version. That makes sense because you need to know what version of the JVM you're using. All the demos and samples that were being shipped with the JDK, very much out of date, so they have been removed as well. Other things that have been removed from the JDK 9, there is a JVM tooling interface, hprof agent, only ever intended as a demo, so there's other ways of doing that with things like JMap. The JHat tool was only ever experimental, introduced in JDK 6, never been supported, and again, better heap visualization tools available. Several of the GC options were deprecated in JDK 8, and now they have finally been removed. Things like the parallel new and serial old combination. Don't know why anybody would do that, but apparently they do, so it's gone. A lot of things to do with incremental concurrent mark sweep. Those things have all been removed as well, so they were deprecated in JDK 8, they're just going away. One last thing to mention is incubator modules. So incubator modules have been introduced as sort of making use of the module system, but allowing things to change in a better way. The idea of this is that designing an API is very difficult. What you don't want to do is have somebody design the API, put it into the JDK, fix it in the standard, and then we discover it doesn't quite work the way people want it to. So the idea of an incubator module is we put the new API into the JDK, let people try it out, see what they think of it, and then when changes need to be made, we can do it in the incubator module before it gets put into the standard API. At the moment, JDK 9 only has one. That's the HTTP2 module, but that basically means that there's something you can play around with in that. Just to summarize, since I have a minute and so, JDK 9, the big new feature is modularity, obviously. Lots of different areas are affected by modularity, encapsulation of internal APIs, the ability to do things like jlink and so on, all these very good things. There are lots of smaller features, though, as I've been through. So things like new APIs around streams, the reactive API, some of the concurrency updates, things like that. REPL, JShell, many changes in terms of smaller performance and standards things. And what I would say is that because you've still got till September before the final release comes out, it's really important to start testing your applications with JDK 9 now. We're actually almost at a point where it's going to be the release candidate in a couple of weeks' time. So it's very much going to be what it looks like in September. There's only going to be some bug fixing happening between now and then. My other marketing slide, I'll just very briefly, that if you're interested in Java, we have a build of the OpenJDK called Zulu Java. It is free. We support versions 6, 7, 8, and 9 early access. As I say, it's free. If you want to pay us for support, we will quite happily take your money. And you can get it from zulu.org/download. We also do versions for the ARM architecture as well. So with that, thank you very much.